Alright, so this video is going to be about solving for specified variables, and it also can be known as manipulating an equation. If we take manipulating a formula, so this video is going to cover that in a little more depth. So what we know is that we want to solve for x. It says that y equals mx plus b for x. That's how we know what we're going to look for. So first we find where x is. And then that's what we need to look at first, is x is right there. So we need to think about what we need to do to get x alone. That's what it means by for. I'm going to say that again. So the object is to get x alone. That's what this means. When it says for, it means that. So we want x alone on one side of the equation. So there's some things that we can do to get it there. Algebraic manipulation works every time because these variables are just numbers. So that's what you have to remember, is that these variables, they're just numbers. We just don't know what the numbers are. So they act like numbers in this equation, because if we did know numbers, we could solve for specific variables. But if we don't know a number, we can't solve. So that's the hard part, is when we're solving for specific variables. Like if you look at your textbook right here, solve for specified variables, it doesn't work to solve like we would solve this one. It won't deduce down to a variable and a number. So this one, if you think about it, if we do something like this, it'll give you an answer that looks like this. It'll give you an answer with like an x equals 3. So an x equals some number. So think about that for a second. And pause the video if you need to. I'm making this video so you can rewatch parts of it. I'll pause at specific sections where things are important. So the important thing for this section, the variables act like numbers. You will not get an answer that looks like this. From solving for a specified variable, your answer will not look like this, because we have more variables than we have known numbers. So this will not be what your answer looks like. Instead, your answer will look like x equals a bunch of letters. Again, I'll say that. Your answer will be x equals a bunch of letters, because letters can't be combined or crossed out by other letters, unless it's the same letter. But we have all different letters, so it's not going to work that way. Alright, so the first step is to work on getting x by itself. If we look here, we notice a plus here, and we need to get rid of that before we can divide by m. The plus always has to be gone, because we're going through the order of operations backwards. When we're doing algebraic problems, we go through the order of operations backwards. We say that we want negative b, so minus b from both sides. And I'm going to say that this so that's something to look at. When we're minus b, it can't be combined to y, because they're different. So therefore, mx must equal y minus b. That's just how it must be. Because we've solved the equation to solve that. If we knew what b and y was, we would know what mx is, but we don't know. Therefore, it stays like that. Let me say that again. We don't know what our variables are. Therefore, they cannot be combined. So think about that. The variables are different. They can't be put together. Therefore, y minus b is an appropriate thing to write. Alright, so if y minus b is appropriate, then we know that we can't deduce that down anymore. So we're going to take and we're going to divide by m. This can also be written as this. They equal the same thing. So if I were to say that x equals y minus b over m, or y minus b over m equals x, it's the same thing. There's nothing different about those two equations. If you plug in the numbers, you will always get the same number for x. There is nothing different between how those are written. You can flip-flop things on the equal sign to make things easier to see. And if you look, this answer down here does not look like this answer up here. And that's because we don't know what all these other numbers are. If we did, it could be 3. We don't know. That would only be if they gave us something like saying that y equals 6, b equals 0, and m equals 2. Then we could plug in those numbers and solve the equation, but they didn't give us that. Oops. They didn't give us that, so we can erase it because we didn't get that in our equation. Instead, we just got this to solve for x. So now we've taken a formula, so we'll call this f1. And made it into f2, or formula 2. This formula solves for x. I'll repeat that again. We took one formula that solved for y and turned it into a formula that solves for x. This x equals the same as this x here, but in this equation it's covered by a bunch of stuff. In this equation we removed that stuff and got x by itself, so we can find what x equals if we knew the other values. Alright, now I want you to think about that. I'm going to switch gears and use the same equation to solve for a different variable, and I want you to keep track of that. But you can stop here if you'd like and rewatch the rest of this, rewatch the beginning of this, because that'll go back over this equation. But I'm going to use this equation to solve for a different variable, and hopefully that helps you. So again, I'm going to use this equation to solve for a different variable. We're still going to name it formula 1. I'm going to delete some stuff here. I got some extra stuff. Alright, so say we were given this formula, but instead of solving for x, they want us to solve for b. So instead of this, they say solve for b. Okay, so we think about this. B is right here. Okay, again, the object is to get b alone on one side. What are we doing to b that makes it so it can't be alone? Well, we're adding an m times an x to b. Okay, so if we're adding an m times an x to b, if we wanted to get rid of that, we would subtract an m times an x from both sides. That's our answer. Let me go over that again. If we know that this b has an mx added to it, then to remove the mx from the b, we would subtract mx. Now mx cannot be subtracted from y. There is no mx in y. Mx cannot be subtracted from y because there is no mx in y. So it is appropriate to write this on this side of the equation. So therefore, to find our b, it's y minus mx. And now we have solved for b. We've taken an equation that solved for y and solved for b. The object of these equations is to show you how to use algebraic manipulation. That's a big word for using your algebra skills to change an equation, to change a formula. So it's important to think and to remember, again, that each of these variables is a number. We just don't know what the number is. But they're all different letters because they represent different numbers. So they cannot be added, subtracted, or divided, or multiplied into each other because we don't know what the numbers are. That's why they stay separate, with just the operations in between to show you what we did. This is how you solve for specified variables. You find the variable you are looking for, whether it be b or x, and you figure out how to undo it. In the case of b, we added an mx. We can put a plus here. So we added an mx to a b. We needed to get rid of that. We subtracted an mx, and we got rid of it. Going back to our original, solving for x, we multiplied by an m, and we added a b. So the first step is to subtract b because we added a b. That was the last step we did to make the equation. So it's the first step we do to undo it. So we subtract a b. And then the next thing that we had done originally was multiply by an m. So to undo that, we divide by m. That division is to undo what we did to x, and you will see that in the first part of this video. This explains how to manipulate an equation. Let me know if you need another video on the subject.